simple interest is only paid on the amount of money that you actually deposit into the account. And the problems that we're doing in section 3 are you make one single deposit and you never touch it again, and you make the calculations. And the reason we do it that way is because it's very difficult and time consuming to calculate simple interest for multiple deposits, because you have to calculate a new problem every single time you deposit money. But there are bank accounts that do pay simple interest. It's just that the computers do all the calculations for them. Okay. Compound interest earns you more money. Compound interest is paid on the initial money that you put in the bank, so all the money that you put in there plus any interest the bank has paid you. So let's say you put in $50, and just because I'm going to use an easy example, it's totally unrealistic. Let's say that $50 earns you $10 in interest. Then when they do the next calculation, they calculate off of $60. And if that earns you another $10 of interest, the next calculation will be off of $70. So the interest gets included in the calculations, and so I was just using 10 each time. It wouldn't really work that way. Because it's getting calculated on a larger amount, it would say $50 would turn into 60. And then when they calculated the interest, instead of getting $10 again, you'd get $11 or $12. So then instead of being calculated on 70, it would calculate on 72, which would then earn you maybe $14. So then the next calculation would be on 86. Does that make sense? So you get, it grows faster because you're getting calculations on top of what they've already paid you. So it's not just the money you put in, it's the money the bank puts in combined together. And then there's different periods of time when they do these calculations. There's annual compounding, and that's when they calculate annually at the end of the year, or you know, if they decide their day that they do it is in June, whatever day that is, every year on that day, they do the calculations. There's semi-annual, which is every 6 months, so twice a year. Quarterly is every 3 months, so 4 times a year. And then you have daily, which is every day, 365 or 66, depending on if it's a leap year. And then monthly is every month, so that happens 12 times a year. And you'll need to know these numbers because when we do the compound interest formula in the next section, the 1, the 3, the 6, the 12, and the 365, and I'm just going to throw it in here, if it's weekly, it's 52 times a year. These numbers get plugged into the equations, so you need to be familiar with these. Semi-annual is 2, quarterly is 4, monthly 12, weekly 52, daily 365 or 6. Okay, crediting occurs when they actually put the money in the account. So let's say you have an account that pays daily compound interest. The bank is not going to put that money in your account every single day. What happens is the computers keep track of everything, of course, because in a savings account, unless you have a pretty substantial chunk of money in there, the daily interest is going to be in the pennies, less than $1. So let's say you earn interest of 15 cents on the first day of the month and 16 cents the second day of the month, 17 and a half cents, 18 and a quarter cents. You know, it's not even, and every day they do these calculations, and the computer keeps track of here's the money that's in your account, here's the interest that you're owed, and does the calculations, but they don't actually put it in your account until the end of the month. And that's because when they're doing the calculations, they don't round at all on a daily basis. They keep those decimals. So if it turns out to be 13.6 cents, if they were to put it in your account every day, they'd have to give you 14 cents because there's no such thing as a 0.6 cents, right? But they don't want to give you that extra 0.4 of a penny. So they do calculations and then they round at the end. So at the most, they're only ever rounding up 1 cent instead of 1 cent every day. Does that make sense? Okay. That way they're only giving you like an extra part of a penny instead of an extra 30 cents or something. So they credit the account on certain periods of time. So if it's annual or semi-annual compounding, they usually credit it right at that time. But if it's like daily or weekly, they credit it at the end of the month. And then some banks might do, I don't actually know of any banks that do annual compound or annual crediting on like a monthly account, but I guess they could. Usually they'll let you know that though in the big paperwork that nobody ever reads that the bank gives you about your account. All right, so how much interest $1,000 would earn 1 year at a rate of 6% compounded annually? So it's only going to get calculated once a year. We're going to use the simple interest formula on this section because we don't know the compound interest formula yet. So we have $1,000 at 6% for 1 year. That is going to give me $60. Okay. The balance would be 1,000 plus 60, so 1060 at the end of the year. Now, if I'm doing semi-annual, right, this is going to happen 2 times. I'm going to take that 1,000. Now, it's only 6 months. It's every 6 months, so T is going to equal 1/2. Because it's half a year. And when I do that calculation, I'm going to get $30. So her balance will be 1,000 plus 30. And that's at the 6-month mark. Now, on the second 6 months, when I do the calculation, it's not the original 1,000 anymore, it's 1,030. Still half a year. And when I calculate that out, instead of being $30, it's now $30.90. And her balance same amount of money between these 2 accounts, same amount of time, 1 year, but the fact that they calculate the interest twice instead of just once earns her almost a whole extra dollar. Okay, so same formula. So in the first quarter, I'm going to do 3 months, so it's 3/12. Here, actually, since I'm going to get you guys in the habit of this, I'm going to do 1,000 times 0.06 times 3. And that'll give me 180 divided by 12. So it's $15. So the balance would be 1,015. So that's the balance after the first 3 months. When we get to the second quarter, which is 0.25, you can use that as well if you want. I get 182.70 divided by 12. So she gets 15.23. So that second quarter she's earning an extra 23 cents. Then in the third quarter, oops, not 10, 15, 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. 10, 30. you wanted to do the decimal, you could do 0.25. So now she's got 1545. And then in the fourth quarter, okay, so simple interest just the 1 year. She earned $60, but by doing that calculation just 4 times, it already increased it $1.37. And I know that's a small amount, but you're talking about a small deposit too. You're only talking $1,000. If it was $20,000, that's going to make a huge difference. Do you guys see that? So the compound interest, it grows a lot faster because the larger the amount of money that you have in there to begin with, then that interest payment is larger, which makes the interest that's calculated the next time that much larger, and you know, it just snowballs. We're not going to do the whole year on the daily thing. That would be 365 calculations. That would be silly. But we will do, we have 1 day. So I'm going to do 1,000 times 0.06 and then divide that by 365. So the balance after 1 day would be 1,016 cents. Okay, so you're going to have problems similar to this in the homework. And I'm going to tell you right now, absolutely one of these on the test. Okay, there's 2 problems like this in the homework. One will be assigned, one not, but I would recommend doing both because this is a test question. Okay, so on the beginning of the day, on July 11th, she has a balance of $1,234.98. She withdraws $200 for car repair and then receives a $34 check and deposits it. So she subtracts 200 and then adds 34. So I'll take that 1234.98 minus 200 plus 34, and her new changed balance is 1068.98. She's going to earn interest on this for 1 day. Okay, she compounds daily at a rate of 3.2%. So 1 day is 1 over 365. So I do the 1068.98 times 0.032. And then I divide that by 365. So she earns 9 cents. So her final balance is going to be to add that 9 cents in. Okay, Okay, so that's her balance at the end of the day on July 11th. Yes. Okay. Now, whatever the day ends with on one day, whatever amount you end with on, say, Monday, is the amount you start with on Tuesday. Okay. On July 12th, she deposits a paycheck. So she starts with the 1069.07 and she deposits a paycheck. And now she has 1414.84. Okay. Then we calculate the interest. It's one day, so again, it's over 365. So I multiplied across the 1414.84 times the 0.032 times 1 technically. And I get 45.27488 divided by 365. And on that day, she earns 12 cents. And so this is what we're looking for, her balance at the end of the day on typoed July 12th. Okay. Yeah. Okay, the compound interest formula. When we did the simple interest formula, we had principal, rate, and time, and it gave us interest. And then we had to add that interest in to get the balance. The compound interest formula gives us the principal, the interest rate, the number of times that the compounding occurs during a year, the number of years, and then it gives us the balance at the end. It does not actually tell us the amount of interest that's earned. It tells us the balance in the account. Then remember I had said APR and APY, and I tell you the difference? APR is the annual percentage rate. This is the percent number that's used to calculate. This is the one that gets plugged into the formula. Okay, but because it's not simple interest, if you're calculating it at a 1%, it calculates at 1% now, and then it calculates at 1% again, and again, and again, and you actually earn more money. We talked about that with the compounding process. That's when you get your annual percentage yield. And the yield is the earned money divided by the initial deposit. And because it's compounded more than once per year, the yield will be higher than the rate. Okay? And because of that, the banks, when they're trying to get you to open accounts with them, will advertise not the rate that they're actually calculating, but they'll advertise the yield because it looks cooler. I mean, it's higher number, so it looks better, so it's more marketable. So when you look at things like that, you want to look at if they're saying APY or APR. If they're saying APY, know that that's not the number they're going to actually calculate with. The number they're going to actually calculate with is a little smaller. Okay. Okay, so for our compound interest formula, the B is balance. That's the account balance. The P is the same, that's principal. R is my rate as a decimal. Okay. N appears twice, here and here. This is the number of times compounded per year. number of years. Okay. Time in years. Principal? The reason I do this first is because it's going to most likely be a whole number. But even if it's not, I just need to do it first. Get it out of the way. Then, after that, you want to do this division. Okay. Then, after that, you take whatever answer you got from here and you add 1 to it. Okay. After you do that, you take this answer and you raise it to the exponent. You do that fourth. And then the very last thing you're going to do is take whatever you get from that and multiply it by p. Okay, so just as a quick example, let's say we're doing quarterly for 5 years. Yeah. Ooh, that didn't look good at all. Okay, so this is how we go through this. This is the steps, and that's what it looks like. But when we do this on the calculator, I want to show you how you can do that without having to write all that down. Okay? And I'll do that in just a second. Okay, same problem. We do the 4 times 5. That's my exponent 20, and I will write that down. So if I'm working the problem on a piece of paper, and I had that 1,000, like that, what I do is I cross this out and I write 20 up there. Yeah, I just want you guys to be able to see the calculator too. So that's okay. Is that better? Kinda? I need you guys to see the buttons too though, so I know this light stinks. Alright, so I cross out the exponent part and I write in the new exponent, and then I don't mess with this anymore. Like what I do next, I go 0.06 divided by 4. That's that answer, plus 1. This button right here is to the power of. So I do the to the power of 20 times 1,000. There's my answer. And I didn't have to write down all of those long decimals. I also never rounded during the process. So I kept my accuracy until the very end when I round this 5 for the penny. Okay. This button on this particular calculator is the exponent button. So you'll either have that button, you'll have a button that looks like that, or you'll have a button that looks like that. And that's how you'll enter exponents that aren't squares. If you don't have a scientific calculator at home, which is fine. I'm not requiring you buy one. You know, when you open the calculator on the computer, it looks like this, right? You can turn it into a scientific calculator. I don't know if everybody knew that. And that's the button right there, X to the Y. On your iPhone and some Androids, you turn it sideways. And on the iPhone, let me pull up my calculator real quick. On the iPhone, it's a XY also. Okay. Oh, you guys can't see that. Yeah, you can. Right. It's right there. It's XY. So if you don't have a scientific calculator, that's okay. You can use your phone. You can use the one on your computer. In class, these will be available for you. I have a class set of these, and we'll work on how to use them. We're not going to finish this section on compound interest today. We're running out of time. So I'm just going to stop here.